So this is an important benchmark for you. If you spent less than 2 hours on this, you are on track. That is about the level of expertise you should be at right now. If you spent more than that, then that means you might be struggling a little bit with some of the fundamentals. If you're struggling with fundamentals, that's a real good reason to go back, if you have the time, and redo some of these earlier courses and make sure you can speak the language of R pretty fluently, because it will only get more complicated. We're only going to be adding new layers on top of what we've already done. Again, this is like basic. I basically gave you an alphabet and some basic vocabulary. Imagine trying to learn English without knowing what the and of mean. So it would be a lot harder for you. So if you spent more than 2 hours on this project, really think about why that happened. And think about ways you can optimize your learning, either going back through existing projects or going back through existing data camp courses, going back through existing projects, or trying to supplement your education with web-based resources. So please think about that. This particular project is really about applying some of the more important pieces of what you learned in Intermediate R. This is not to say that if it didn't appear in here, you won't be using it, because you probably will. Almost everything in Intermediate R you're going to end up needing at some point. So just be aware it all exists. This is just kind of an intro a little bit to it. We're going to do like we did last time, in that we're going to step through these projects piece by piece in here. I'm going to demonstrate how I would do this if I were writing this code. I added one requirement to the top of this, which I hope you saw. I meant to mention it last time, but I didn't. All code must be scalable by sample size. That was not true in the last project, because I didn't write it in, and it should have been. And a few people did things like, instead of using ranges for comparisons, they said, if case number equals 1, 2, 3, 4, do blank. Do not do that. And that was actually, that was okay last time, because I didn't tell you not to do it, but here you don't do it. So, for example, one of the comments that I got, one of the emails I got here was, everyone that participated in June was a research assistant, create a new frame that only contains them. That meant that you had to write code that eliminated people in June. That didn't mean that you could open the data set, see who was in June, and eliminate them one by one. Those are different things. So it had to be scalable. So you had to do it that way. I didn't mention last time, but I hope it was obvious from the grading interpretation, there are 2 levels of mistakes in here. There's a major error and a minor error, and I'm pretty sure everybody in here made at least one of each. No, not everybody made major errors, but most people got at least one major error and one minor error. What that means is a minor error means you didn't do exactly what I told you to do, but it still worked. That's a minor error, and you lose 1 point for doing that. So if you made 5 little mistakes, you got like a -5. Major errors mean you fundamentally didn't do the thing that you were assigned to do. For that, you lose either 5 or 10 points, depending how important it is. Okay? So that's the grading system in here. So as long as your code is functional, you shouldn't lose very many points, even if you don't do exactly what I say. If when you have this, when I look at it for a particular line of code and it's not in the right place, so I can't find it, or if it's not actually accomplishing what it's supposed to accomplish, then that's when you lose more points. So just a little clarification over how the grading system works. Does that make sense to everybody? So that's important, again, because as we move forward, little mistakes will become big mistakes. Right now, there's a little bit of flexibility because these are relatively small requirements. Once I get to later assignments where I'm asking you to do 5 or 6 things in one line, if you don't get the right output on that line, then the rest of your program won't work. That started to happen a little bit here. If you screwed up earlier in this project, then you might have noticed later code that should have worked didn't. So that's going to happen more and more as we get more complicated. Okay, so let's do it. So requirement 1, create the RStudio project. Again, next time I'm not even going to write all that in. It's just going to say set up your RStudio project. So make sure you're familiar with this system. I'm going to hit a new project. I'm not going to save because I don't care. New directory, empty project. We're going to put this somewhere interesting. Walkthrough. And I'm going to make a new, no, I'm not going to make a folder. I'm going to call this week 3, create project with Git. Switch over, new folder, docs, R, output, figures, and I'm missing one. What's that? Data. I'm going to use this button because I just like it. to show a folder a new directory, just so I can make sure that it looks right in my own system. I'm going to go back to over here. Going to save that file that I needed where I need it. Save link as. Going to put this in teaching, data science, projects, walkthrough, week 3, and data. Done. If I go back over here, I should be able to find it. Yep. If I go into R, I should be able to find it there too. Yep. So everything looks good. I'm going to create a brand new project, script file, and I'm going to immediately save it. That was Alt-F-A, if you didn't see me do that, to, what did I need to call this? It's in the assignment. It needs to be week3.csv. No, not CSV. Whoops. week3.r. Again, go back over to my data just to double check, and week3.r. One of the weird things that Windows does, by the way, is sometimes it hides file extensions from you. This was a mistake that a couple people made on the very first one. So you would end up with a file called something like week3.r.r or something weird. Make sure that they're actually named correctly. That will matter more later, too. All right, so then we have a blank file, week3.r. Going to go line 1, write a comment that says data import and cleaning. Line 2, call the RStudio API library. In order to get that to work, you could have done it in one of two ways, which doesn't matter as long as it worked. You could have used the install.packages command, which would have required the use of quotes. Alternatively, there's actually a menu-y way to do it. I don't actually know what that is, but there's a way in the menus to do it. It's probably a tool. Yeah, in tool install packages, you can probably install it that way, but it's just honestly a waste of time. So, next command. Set WD to drname to RStudio API : which we'll talk about in a minute. Get active document context, and we're going to call path from that. Who deconstructed that? Nobody? We're going to do it now. So this is actually multiple nested functions. There's a little bit of a unnecessary piece in there, which is that. This code you will actually use in the future occasionally, but what it does is it says, get this function from this package. That's all it does. If you don't have that there, it doesn't actually matter most of the time. Where it matters is if this function is defined in two different places in your code. So if, for example, I imported RStudio API and I also imported another library and they both had a function called getActiveDocumentContext, R doesn't know which one you mean. So it's going to default to the last one you loaded, and if you need to tell it explicitly which one to look in, that's the code for it. In this case, getActiveDocumentContext really it does only exist in one, so I can run that and it still works. See the difference? So that's no different than the other version of the code. Let's actually keep piecing this through. GetActiveDocumentContext is the function itself, so let's see what it does. That returns some weird looking stuff. Let's save it as a doc variable and see what it is. Oh, it's a list. When I look in that list, I end up with an ID variable, a path, contents, and selection. And that means that I could, in turn, use this to refer to any one of those pieces. And if I write $ in console, will it? No, it doesn't. I can select one of those that I want. Contents is going to return an empty string. ID is going to return, in this case, hash console. See what I'm doing? Just exploring what this function does. I'm not actually doing anything for the code project yet. So what is it doing? It's pulling the path variable out. Well, path right now says nothing. Why is that? Do you have a sense of what this does yet? What's it pulling from? The ID is a clue. And the name of it, RStudio API. What happens, and this will give you a lot better context, if instead of running this here, I run it here? What changed? Yeah, you see it, don't you? Suddenly there's all sorts of stuff here. I actually have the contents of the file that I'm working in. I have an ID number that who knows what that means, and I have a file path right there. This is what RStudio API does. It grabs information about actively what you're doing in RStudio and returns it as variables. So that means if I look at path up here, I'm going to get something about the path. I'm going to type it down here so you can see the whole thing. I'm getting this thing right here. This is where I just saved that file, teaching/data science/projects/walkthrough, and you should recognize that as the directory I just created everything in, week3/r/week3.r. Okay? Why can't, and I'll give you this right here, setwd, I bet you can guess what that does. Set working directory. So now there's another function in the middle. Why do you think that is? What does this return? Is this a valid path? Does that look like a valid path to you? What is that? A tilde. What do you think he does? Got to deconstruct. This tilde means current documents folder. And on my system, that's defined as the documents folder on my D drive. If I send that to setwd, that won't work, because setwd doesn't know where my documents folder is. But I can layer that inside, I bet you can guess, dir name, and suddenly I have a full path. User documents, etc., etc. That is then what gets fed into setwd. So this just automatically takes where is the name of the current file I'm working in that I'm running this statement from, get the path out, convert it to a full directory name, and then set it as the current working directory in RStudio. That's what that does. Anytime that you see commands you don't know how they work, take the time to try to piece it out. If you don't understand it after you do that, it's fine, but try. Like literally pull it apart and see what each piece does and try to figure out why. All right, so that was all unnecessary up here, so we're going to just keep going. Line 5. Skip a line. Use read CSV to create a data frame called r_df from the CSV file you got earlier. So we want to call that raw_df gets read.csv data week3.csv. We're going to double check that that actually worked. Yep, we have a data file. If we look at the types, we see that it is automatically identified as 4 factor variables and a bunch of integers. So the next command is about dates. Why? Why do we need to pre-process those date columns? I see people with ideas that aren't saying them. Come on. Related to subsetting. Why? Can't subset based on a factor. Well, you can subset based on a factor, but you can't subset in certain ways. I could, for example, with a factor say all cases where that string equals. I could do that. But can I use less than greater than? No, because factors are strings. Actually, factors up here are going to be represented as numbers. If you could see all the way over, you could see that what it's done is it's renumbered all of those as 1, 2, 3, 4, 5 in a totally random order that makes no sense. So instead, we need to convert that into an underlying format that can be compared with less than and greater than. So that's why that next command is there. So this is the POSIX format. How is a POSIX date treated in R? It's not treated as a character vector. What is it treated as? Numeric. Well, it's a class that contains a numeric. Yes. And what is that number? It's a date you got to have in your head. It's the number of seconds that have elapsed since January 1st, 1970 in universal coordinated time. Very important that you know what that means. Also called the Unix epoch. It is the origin of all computing, essentially. Because when they created that, they said, no one will ever need to refer to dates before that time. Now, in the present day, if you do need to refer to dates before that time, it becomes negative. So this ends up just being a sort of marker point. So that time is 0. And everything above that is positive, and everything before that is negative. Okay. January 1st, 1970, at 00:00:00, exactly midnight in Universal Coordinated Time, which is equivalent to Greenwich Mean Time, most usually, about an hour west of London. Okay. We're about 5 hours, I think, off of that, depending on daylight savings, because daylight savings is stupid. We're about 5 or 6 or maybe 4. It doesn't really matter because it does it for you. So that's really the advantage. You don't have to care. That's why it's such a useful thing. Okay. So we now have a successful import. We're going to recast time start into POSIX. What function do we use to do that? As POSIX CT, representing a calendar date and time, and we're going to do that with itself. At least this is the way I would do it. There are actually a few ways to do it, so you may not have used that exact approach, but that's, I think, the easiest way to do it. Remember that recasting is done with as. The other version of that is checks, returns Boolean true or false. So before, if I had done is.posix on that, it would have returned false. Now that I've converted, if I did is.posix, it would work. It would say true. The next line is convert the next one, right? Yep, recast time end. So raw df time end gets as.posix ct raw underscore df time end. And you can see how that's changed over here. We now have 2 POSIX CT formats instead of the factors that we had before. The usefulness of that is that I can convert them easily back into the Unix epoch, into times. And then it's much easier to understand which dates are bigger than other dates. Line 8. Everyone that participated in June 2017 was a research assistant testing the code. Create a new data frame, go ahead and write that, called clean df. Create a new data frame that contains only real participants. Because everybody knows research assistants aren't real. All right. So if we are to exclude the research assistants, how could we do that? This is the first truly ambiguous thing I told you to do, because there are like 5 or 6 different ways you could have done this.
So I just did everything greater than or equal to July 1st. Since all the research assistants were in June, and there was nothing in May.
Everything was...
Oh, I'm sorry, I subset.
Subset, okay.
The raw data frame.
Raw df.
With time start.
Time start.
Greater than or equal to. Parentheses 2017-07-01.
Parentheses 2017.
I'm sorry, quotation marks.
Oh, quotation marks 2017. What?
Dash
7
dash
01. Okay.
So it took out 7.
So the goal here is to, remove everybody that participated in June 2017. I'm actually going to sort this so we can just check. Success. Wasn't that easy?
A lot of trial and error.
Another approach, if you want to be more explicit about it, because something weird is happening here that you might not have recognized. That is actually, that date is having to be coerced into POSIX. If you wanted to be more explicit about it, you might have done this, which is what I would have done. Both work. Any other approaches? Anybody do this the hard way? Yeah.
I don't know if it's the hard way, but I also added a pipe, and it said time start smaller than anything else that was before June. But it would be more inclusive. Because we only want to exclude people who are in June.
Yeah.
If they're very participating before June.
So you subsetted, you subsetted not before June? Is that what you're saying?
I subsetted people did the same thing that you wrote earlier, but then had a pipeline. And then said time starts smaller than 2017-601. So if there are any participants who participate.
Oh, I see. Oh, that is more technically correct. Good. I hadn't even thought about that. So since the instructions said June, then you might have excluded people before June and people after June. That's very good. That is technically correct, the best kind of correct. All right. So any of those approaches would work. There are more complicated ways that you could have done it. My favorite, and I hope somebody did this because it's so fun to see, if you went into the internet and you tried to convert June 1st into a number and got the Unix epoch, the date, the time, the number for June 1st, or for July 1st or June 30, June 30, yeah. Then if you took either of those and threw it in there, it still would have worked. But you would have done that conversion manually for yourself. Either of those work. There's a lot of different ways to do this. Did anybody try to do subsetting based on brackets? Yeah, that's the advanced approach. It's also way harder to read. It worked, yeah? Yeah. You can use brackets the same way. Remember that you can subset a list, which is what a data frame is, using brackets and then date greater than. So you could do something, I'm going to write this on the fly, so I'm probably going to get this wrong. Raw underscore df, and I'm going to use list items. Oh, man. I'm going to coerce it into a matrix, so that means I want to do variables where time start greater than or equal to as.posix ct 2017-0701. Is that right? Is that what you did? I think that works. Let me go back to raw, make sure. Dun, 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 and subset. No. Oh. We need raw df, maybe? Whoop.
The comma has to do that.
Oh, I flipped it. I always flip it. Damn it.
Just selecting rows without columns.
Yeah, you're right. There we go. See, it's harder to read. But that is the same thing. It does exactly the same thing. Yeah.
I did it different because it didn't say that there wasn't real participants before the lab students. So I reformatted it so that it was only year, month, and then said not equal to 2017-06.
Oh, that's a lot of extra work, but yes, also technically correct. It's bonus points for being technically correct, by the way. So good. So, okay. So all of these would work. It doesn't matter which one you did as long as you actually did one that did work. So that is the key here, and was within the lines of the assignment. So great. Yeah. See, this was the caveat here. It was in this file, and the file did only contain cases that were either in June or after June. So those are still correct, but the previous June, technically, that is a better interpretation of that statement. So good. All right. Clean df next. This should be a little easier. Question 6 read, if you're paying attention, answer strongly agree or strongly disagree. Update cleans df so it only contains people who are paying attention. How do we do that? Good catch. Yep. We're already working on clean, so we got to keep clean.
Subset equals question 6, or subset is question 6 equals 4.
We could write it that way. Notice that I used equality, not gets. If you used the gets there, then you would have eliminated all of the cases. I also don't actually need to write subset. That also works. Because subset's the second term, as we talked about last time. It eliminates 3 cases. Okay? Everybody with me up here? Great. We go back here. New section, line 11, analysis. Line 12, save the total time spent on the study by each participant in seconds into a new variable in clean underscore df called time spent. Using diff time, you may need to use the documentation to figure out how diff time works. So we'll go ahead and do that. All right, diff time. Time intervals, creation, printing, and arithmetic. Print method calls time differences. Usage. Man, that is a real easy way right there. Subtract 2 times. That's a very straightforward way to use this function. Note that it actually means you don't have to use the term diff time to use diff time. If you just subtract 2 things that are POSIX variables, it will figure it out. But if you want to specify units, you would need to use this version. And so in this case, the assignment specifically requested that we wanted seconds. So that's a key piece of this. There's a number of different ways you could have done this. What'd you do? Yeah. Yeah.
Is it wrong if you did
As dot diff time? Oh, I see. So as a time difference, and then, but you still would have used the second diff time to get that.
I did as diff time, parentheses, and then parentheses, via time n minus via time star, parentheses.
Well, that's, yeah, because a time minus time is a diff time, so you put a diff time inside an as diff time. It still works. That's a minor error, though, because you used a different function. You used two layered functions unnecessarily. 1 point. As long as it still worked, though. That's what's important. A key outcome here, remember, by the way, is for me to help you create professional code, not just functional code. So we're going to work toward good formatting. So yeah, if you used as.diff time, parentheses, time minus time, then that means this is actually a diff time because that's there, and you're putting the output of diff time into as diff time. So that's just 2 functions instead of 1. So if we did it, what other ways? What ways do people use? Who actually just subtracted it? What'd you do after you subtracted it then?
Well, I don't think I did it right. I did diff time, and then time n, or diff time $time time n. I'm sorry. Diff time parentheses, clean df $time n, comma, clean df $time star.
Anything else?
No.
Oh. So if we did that, what happens? We have minutes. What is the easy way to fix that problem?
And you put comma municipal sex.
There's an easier way. Yeah, portions of minutes. Actually, it's not times. It's no, it is time. We have to do it as numeric first, I think. Maybe it's not that easy. I put my parenthesis the wrong way. Am I doing it backwards still? There we go. Yeah, you're right. Sorry. I'm reversing. So there's an easy way to do it. And I don't think you actually do need to call as numeric. I think it'll coerce by itself. Let's test that. This is development. This is how you find these things out. Yep. So it'll converse automatically. So that would be the easy way to do that. Alternatively, you could do it inside diff time. How? Same outcome. Either of those would work. You also could have done this super easy, because this is still diff time. Maybe you couldn't. Do I have to coerce it? There we go. I have to coerce it. So the reason that those are different is because this is, again, a function. So it's expecting this exact format. When I put a time minus time times something, it says, aha, that's not the format of this function. So it tries to do it algebraically. And you can't add a POSIX to it. You can't mathematically operate on 2 POSIXes and a integer at the same time. So that's why I threw the error. I put the parentheses around it to say this is self-contained, which then coerces it into believing this is what you should use. So that's the difference between all those different versions. Any of those are fine. As long as it worked and you ended up with seconds in that column, those are all correct. But hopefully you're starting to see now, though, why code is so personal. why it is very language-oriented, why I gave all the warnings in the beginning. If you work with somebody else, it will start to become real obvious real quick. Because there are a lot of different ways to do things. And as we go further, there will be even more. If I just, for example, tell you import a data file, there are at least 24 different approaches you could take to importing a data file. So, just as a reminder, don't work together. I would even advise you not to look at someone else's code, because it's so hard once you see how somebody else does something to get that out of your head. So please don't do that. All right, 12. Create a histogram of time spent. How do you do that? It's easy. You guys just say it. There we go. Hist, what do I put in it? One approach is as numeric, and we're putting as numeric on clean_df time spent. What other way could I do that? Now here I specifically said as numeric, so hopefully you actually did it this way, but I could alternatively unclass it, I believe. Yep. And unclassing accomplishes the same thing. Yeah.
What's the benefit of using one or another?
For this particular problem, nothing.
Right.
So the difference is that you can unclass anything that's contained within a larger class. We haven't really talked about classes, so makes this hard. But what classes essentially are is user-defined variable types. So if I wanted to define something that's not a list or a vector or a matrix, then I could create my own class, and that can contain literally anything. So often classes are used to put a lot of dissimilar information together, all within one framework in R. So the reason, for example, POSIX is a class is because that means that POSIX variables as a group can be treated in a whole lot of different ways. So if we look at just POSIX by itself, let me see if I can pull this up.
So basically, unclass is just overkill.
Yeah, here it is. So there are cases where a class will have a lot of information in it, and you can't coerce it to numeric because there's lots of different types of information that could be converted. So in those cases, you would need to unclass and then look in what got returned, which is probably a list, and then figure out where the information you want actually is. Also, when you unclass, it usually by default only returns the first thing in the class. So if there was other information in the class and you wanted that instead, you wouldn't be able to get it with as numeric. It's very advanced. But yeah. Okay, so in this case, this hist works. We're going to go to line 14. Using list apply, iterate over the 5th to 14th columns of clean df and run the function table, saving the result to frequencies table list. Frequency underscore tables underscore list gets. What does this statement look like? There's actually a couple different ways to do this too. Mm-hmm.
I had parentheses, clean underscore df, bracket, comma, parentheses, 5:14.
5:14. Okay.
Parentheses and bracket, and then I put table. Well, comma table.
Comma table. That's what you did? Okay. Anybody do this differently?
Just left out the comma. Using the brackets.
Left out the comma. Anybody do this differently? The comma didn't have the parentheses. Anybody do this differently? One more version, which if you can iterate, you'd see. Those are slightly different. Why? Well, I'll tell you number one, parentheses are totally unnecessary here. You do not need them. They don't hurt anything, but they're unnecessary. But there's two versions, really, ultimately. We have comma 5:14 and 5:14. Why are those different? Which one is rows and columns? That's the comma version. What is this? Why does that work? You can't apply over rows, but what is this doing? frame, it's pulling individual lists, 5 through 14. Yes. List items 5 through 14 is what this is doing. This one is saying coerce the data frame down to a matrix and return columns 5 to 14. Then it will coerce it back up in order to be thrown into list apply. Again, data frames are lists that act like matrices, which is weird. But that is an important difference in some contexts. Because if you try to do this on not a data frame, if you do this on an actual matrix, it won't work. It will work, but it'll return elements 5 through 14, which in a matrix is very different. In a matrix, items are defined by going down each column, then to the top of the next row. So items 5 through 14 in a 5-row matrix is the last item in the first column, the next 5 items in the second column, 1, 2, 3, 4, 5, and the next 5 items in the next column, and then the next 3 items in the next column. Very different than this. This is a list. This is subsetting a list. Because remember, we could also extract by using double brackets, which would be even different. It wouldn't work here because you need a list for list apply. And here we're treating the data frame like a list, or like a matrix, and then subsetting individual columns. They're both correct here, but you need to recognize that those are two different things. Because sometimes that won't work. Okay? Now here is an interesting thing. Did you actually look at this? At frequencies tables list? See what it is? It's a list. What are those? Yeah, that's what table does. It tabulates. It's essentially the same as doing frequency distributions that we do all the time, except that we've done it for every question individually and stuffed it all into a list. So this is a set of, it's actually a data frame, but a data frame containing one variable per, and for each one it's showing the number of cases within each. That also means we should be able to go down and check, yep, there's Q6, which is the thing we subsetted on. We only have cases with value 1, which is what we would expect, because we subsetted it earlier. All right, line 15. Using lapply again, iterate over frequencies tables list running bar plot. If done correctly, you should see 10 bar charts. So what do I do here? Lapply. Frequencies tables list. Bar plot. Let me tell you, by the way, if you need to look at histograms of all your variables in SPSS, it is one of the most obnoxious things that you can try to do. It's not intuitive. You have to go through all sorts of weird menus and chart builders and crap. And here I can do it in one command. Note. So here I can now look at histograms conveniently of every variable. I can scroll through them real quickly to see if everything's normally distributed. In this case, it really is not. So you would probably not want to run any ANOVAs on this thing. And we can look through each one individually. Now, we just did line 15, line 16. Participants should have answered Q1 with a greater or equal value to what they answered Q2 with, and they should never have answered Q2 with the same value as what they answered Q3 with. Display a count of the number of times in clean DF when this actually happened. Ooh. How do we do that? Several different ways again. Some, okay. Some of what?
Power sign Q1 greater or equal than clean DF power sign Q2. And then I did and clean DF power sign Q2. Exclamation point.
Bang. Bang equals.
Bang equals clean DF power sign Q2.
That is precisely how I would do it. Anybody use any other approaches? Inrow and subset. That is more complicated than this version. But yes, works. Yeah. With a loop? You could. Yeah. That's... Well, so what for does is loops through a vector. And it would loop through a list. Man. You could L apply and then R bind to a data frame for each row where everything worked. That would work. For, I don't think, I mean, you probably could, but that'd be very complicated. Because what for is going to do on a data frame, it's going to iterate through it like it's a list. So it's going to go one variable at a time. So if you did it that way, you would probably need to create an anonymous function that checks whether or not a variable. Oh God, that'd be really hard because you'd have to save the values as booleans for each variable one at a time in appropriate lines because you're integrating information from Q1, Q2, and Q3, but you're only doing it one variable at a time. So you would have to record the values of Q1 and then Q2 and then Q3 and then evaluate them at the end of the loop. So that would be a super hard way to do that. Yeah, I wouldn't do that. Oh yeah, I mean you could do it on a one line with an anonymous function inside an lapply, or for, but I would not do that. Yeah. Again, I mean an infinite number of ways to do basically anything, but there are certainly easier ways than others. Yeah. If you ever find, by the way, and this is a good little check, if you ever find, by the way, that you're working through one of these and you're trying to like add in 18 things simultaneously and manage all sorts of weird variables, you're probably not doing it the easiest way. All of these questions are designed in these projects to have relatively straightforward answers. That's the way I'm writing them. So if you're not finding a relatively straightforward answer, you should look for it instead. Okay. Are we done? Line 16, submission same as usual. So at that point, you would take this whole pack. And again, please make sure that you do it on the base functions here, not on this folder, but instead all these files. Take all the files, send to compressed folder, and that would be your final doc. It got uploaded.